Hello everyone. In this tutorial, we are going to provide a solution to this amazing trigonometric equation which is connected with logarithm. So don't forget to like, comment and share to your learning colleagues. Let's get started. We would like to find the value of theta, which is an angle that can satisfy this equation. The log of tangent theta with the base of cosine theta plus log of cotangent theta with the base of sine theta, everything equal to 0. If you are not careful enough, you can never solve this problem. Why? Remember, it is linked or connected with logarithm. And in logarithm, the arguments can never be negative, can never be equal to 0, always greater than 0. So it means that both tangent of theta and cotangent of theta must be greater than 0. So any value of theta that you can put here, simplify and get a negative result or 0, we don't want it. That's first thing. Then the basis of logarithmic function can never be equal to 1. So let's assume both b is equal to cosine theta, and let's assume they are all equal because they are all bases. I want to treat them the same, and also equal to sine theta, assuming they are the same thing. So this b can never be equal to 1. This is first thing. It can never be equal to 1, and also it must be greater than 0, right? B must be greater than 0. It must be greater than 0, and it can never be equal to 1. But we know that both sine theta and cosine theta have their own restriction, right? They have their own restriction. They must be from -1 down to 1. But because of this, we know that it can never be equal to 1, right? So we remove this. Then we know that it must be greater than 0, right? So we have to remove this as well. So this is what we are looking for. Any value of theta that you find and plug it here and realize a negative solution, we don't want it. And if it is 0, we don't want it. If it is equal to 1, we don't want it. So these are the two conditions we need in order to solve this problem. So let's get started. We can write cotangent in terms of tangent because it is a reciprocal of tangent. So we can write cotangent as 1 divided by tangent. So for instance, if you have log of cotangent theta, it is equal to log of 1 divided by tangent of theta. And 1 divided by tangent theta is the same thing as tangent raised to the power of -1. Right? This is log of tangent theta raised to the power of -1. And according to one of the laws of logarithm, this -1 can now drop down to multiply. So finally, we have something like negative times log of tangent of theta, which means that the whole of this is the same thing as negative log of tangent theta. So we have log of tangent theta with the base of cosine theta minus log of tangent theta with the base of sine theta equal to 0. And once we take this one to the other side, it becomes positive. So let's do that. This is log of tangent theta with the base of cosine theta equal to log of tangent theta with the base of sine theta, right? This is what we have. So if you relate, this is log of tangent theta, this is log of tangent theta. They only have different bases, which means that these bases must be the same. Definitely, they must be the same, which implies that sine of theta must be equal to cosine of theta. On what condition? Maybe we should divide both sides by cosine theta, right? Because sine theta divided by cosine theta will give us tangent theta. And cosine theta divided by cosine theta will be equal to 1. So from here we can take tangent inverse of both sides. Theta will be equal to tan inverse of 1 will be either pi over 4 or 45 degrees. Let me use degrees. 45 degrees. But is this the only solution? Remember that tangent is periodic in every given pi or 180 degrees. So if you add, maybe let me use radian. I like to use radian. Let's call it pi over 4. It's 45 degrees, you should know that. So plus multiples of pi, n pi. But there's a problem. Let me show you the problem. If we have a unit cycle here, this is where we have 45 degrees, pi over 4. Sine of 45 degrees is what? Root 2. Okay, let me start with cosine. Cosine of this will be root 2 divided by 2. And sine of this will be root 2 over 2 as well. So if you consider this n pi, when n is equal to 1, we are adding pi, which is a complete 180 degrees. If you add a pi here, it will take you down here. What will it be? Pi over 4 plus pi. This will be what? 5 pi over 4. So this angle right here will be from here down here would be 5 pi over 4. I just want to show you something. Remember, this is third quadrant. In third quadrant, sine is negative. So this will be negative root 2 divided by 2. But yeah, and also cosine is negative because this is x-axis, which is negative root 2 over 2. But remember, we have stated that this can never be negative. Assuming that you have used 5 pi over 4 as your theta, cosine of 5 pi divided by 4 will give you what? Negative root 2 over 2. And we don't want the base to be negative. So how do we do? We have to return back to where we started by adding another pi. So we have been jumping this. From here to here is pi, but from here back to this is 2 pi. So instead of adding pi, we can add 2 pi. From here, if you add 2 pi, it will come back to where it started. We have another coterminal angle. Keep on adding. So instead of adding n pi, we can add 2n pi. This is why I say you have to be very careful. 2n pi. So now, when n is 1, we have n times 2 is 2. Then 2 times pi is 2 pi. Then 2 pi plus pi over 4 will give us 9 pi over 4. And this will be 9 pi over 4. And if we plug it here, it will satisfy, definitely. So this is our general solution. Theta equal to pi divided by 4 plus 2n pi, for which this n is an integer. And we are done. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.